flying the F-14.
Sorry, is it okay if I record you?
Sure.
Okay, sorry.
And ended up in a squadron that was in Virginia Beach, Virginia. And I was flying off the aircraft carrier, USS John F. Kennedy, and went on several deployments, they call them, when the ship goes out to sea and stays for a long period of time, for months at a time. And NASA started selecting new astronauts. And I was not able to apply at the first time for space shuttle astronauts because there was no internet back then. This was a long time ago. And everything had to go via mail. And from the ship to shore and back again took between 3 weeks and a month. And they wanted transcripts of every place I've been to school and asking questions and recommendations and all those things. And it was impossible to get that done in the time. And I figured, they wouldn't have picked me anyway. But sure enough, when I got back from cruise on this deployment, I was stationed in another squadron that was in the United States at the time. And two of the people in that squadron were selected for the 1978 astronaut selection. And I figured, wow, if they could get selected, then maybe I could, if I would have a chance anyway, if they ever asked again. And sure enough, a couple of years later, they asked again. And I went through all the work to get applied and all that things, went through the interview process and that. And I was actually selected in 1980, much to my surprise. And I became an astronaut and moved to Houston, Texas, to the Johnson Space Center, where that's where the astronauts live. We tend to travel a lot, but we pretty much all the active astronauts live in this area. And after I'd been here for a little while, I was selected to fly on a space mission in 1984. Now that's a long time ago, but that was when the space shuttle was very, very young and early in the program. And it was very exciting. My first flight, I got to fly with Bob Crippen as the commander of the flight. He was the one that was in charge. And he had flown on the very first space shuttle flight. So he was a pretty experienced shuttle guy. And I got to fly with two women, Sally Ride and Catherine Sullivan. Sally Ride was the first American woman to fly in space. And Kathy and I were on our very first flights. And during this flight, we were going to do an EVA. That's a code for extravehicular activity, which is a spacewalk. So during that flight, we went outside the space vehicle in our spacesuits and did a spacewalk. And Kathy was the very, very first American woman to do a spacewalk. So I got to fly with some pretty amazing people. The first launch is very, very exciting time. You've been waiting for quite a while and you've trained very, very hard. And then on the morning of launch, you go out to the launch pad and they drop you off from a little van or a little bus that would get off, and just the crew gets off, and then the van drives away because now this rocket is fueled and it holds 4.5 million pounds of high explosive type rocket material. And so we are ready to get on there. So we take the elevator up 195 feet. It's hard in the pictures to understand how big the space shuttle was, but when it was there with the external tank and the solid rocket boosters and that on the space pad, it's a very, very large vehicle. And we have to go up 190 feet just to get into the hatch, to get into the crew compartment on the very front of the vehicle. And so we get in and we get settled in, and the countdown is progressing down. And pretty soon went, wow, this is a space rocket, and these rocket engines are going to ignite here pretty soon and take me on the ride of my life. Now, one of the questions was I scared? And I'll be honest with you, I was not scared. I'm not concerned about my future. I feel very secure in my future because Jesus Christ is my Lord and Savior. And so I am not worried about where my future is going. But the space rocket is quite an exciting thing. And the countdown came down to 0. The main engines ignited, and then the solid rocket boosters ignited, and whoosh, off we go. And for the next 8.5 minutes, are riding a rocket up into space. Now, people wonder, why do you have to use such a big rocket? Don't you just have to go straight up and get out of gravity? Well, let me talk to you a little bit. Do you see this globe here? I'm just using this as the Earth, as a representation of the Earth. And when you launch up, if you just launch straight up, you'd go straight up. But what would happen to you if you shut off your engines right there? Does anybody know? Just yell it out.
What would happen?
Would you just stay there in one place because there's no gravity? No.
They said
Gravity,
fall down.
the Earth has a lot of gravity, and it would pull
Okay,
you
sir.
right back down like that. And so if you're going to stay in orbit, which is going around the Earth and staying up way above the Earth, you have to go very fast because gravity is pulling you back down to the Earth like this all the time. So what we have to do is get going real fast around the Earth. If we're going fast enough, as the gravity pulls us down, we go fast enough, we miss the Earth. And gravity keeps pulling us around and around. And that is called being in orbit. And so what we want to do is get in orbit around the Earth. And that's going around and around. So gravity, somebody asked, is there no gravity up there? There is a lot of gravity. Everywhere you go in space, there's lots of gravity. But in traveling like this, what we are doing is being pulled down to the Earth, but we miss the Earth. So we are in what's called free fall, where gravity doesn't have, we don't know that gravity is acting on us. We are just like we're falling the whole time. It's like jumping off a really tall building, but you never hit the ground. You just go around and around the Earth. And that gives you that feeling of no gravity, where you can float and you can just sit there and piece, things will, like if I wanted to write on this piece of paper and it stopped and somebody interrupted, I would just let go of the pencil and the pencil would stay right there. Here, that pencil drops, but if I wanted to write on the paper in space and let go of it, it would stay right there. So being in what we call zero gravity is a lot of fun because you can float around and you can play games and everything flows in a straight line. So if you pass something to somebody else, you just gently let go of it like that and it just floats right toward you. So it's a really enjoyable time once you get used to it. And then we go about the business that we were going to do on the flight that we're on. And a lot of times we sometimes deployed satellites. We would operate scientific experiments from the payload bay. We would do spacewalks like Kathy and I did and go out into the payload bay and do what we had to do out there, build things. The International Space Station was completely built and put together by astronauts doing spacewalks, going outside. A pretty amazing feat. And things later on will be done that same way, will be built. If anything you have to get up big, you've got to take up in parts. Because to go as fast as you need to do to stay in orbit, you have to go 17,500 miles an hour or faster. That is really fast. You are going in space 5 miles every second. So say you lived 5 miles away from your schoolroom, or maybe make it 10 miles. Say you lived 10 miles away from your schoolroom. 1001, 1002, you'd be home. That's how quick, that's how fast that we're going when we stay up in space. So a bullet travels around maybe 1,500 to 2,000 feet per second. We're going 25,000 feet per second. So we're going almost 10 to 15 times faster than a bullet. So it's kind of fun to have known that you've gone that fast. But when you're up in space going around the big old Earth, you don't really realize it. You just look down on the Earth and you watch it going by, and it seems to be going by slowly. But then you realize, wow, in less than 10 minutes, we went all the way across the United States. We are going pretty fast. And so, in addition to doing some of the experiments that we do and the deployments and things, we get a chance to look out the window. And my favorite thing was to look out the window and look down at the Earth. The Earth is very, very beautiful planet. It is my favorite of all the planets because it's so full of life. It's got colors like blue and green and brown and white and all the different colors that you can see. And it's just a gorgeous, fantastic place. And we know that we live on this earth. Wow, that's pretty neat. So being in space was, for me, was really neat, but I really like living on Earth. So that's the, there's a lot of things that you can do on Earth that you really can't do in space. You don't get to play baseball, or you don't get to go on vacation because you're inside your spacecraft. And because it's a pretty harsh environment in space, you have to stay there. And so it's kind of a small little space, but you can use all of it because you're in 0G. Being in space, and why do they call it space? Because there's a lot of space there. There's really nothing up there, not very much. And that's why there's a vacuum in space, because there's nothing that occupies the space that's there, very little. And so that's why you can go so fast without burning up. And it's also what makes getting back home a little bit complicated, because when you go back home, you're going so fast to come back to Earth and land, you have to slow down. And the way that we do that is use the Earth's atmosphere, which is the air that you're breathing. And that's what fills all this space around you, that you can breathe and do that. You fill that space with air and all that, but that also causes friction. Now, I want you all to take your hands, put them together and rub them together. Push hard and rub them together. Okay, push harder, rub a little faster, rub a little faster. What happens to your hands?
It got hot.
Get hot. Now just think, if you rub your hands together like that at 17,000 miles an hour, that's how hot the bottom of the space shuttle gets. And so it had to have very special heat resistant tiles so that that heat wouldn't burn it up. And so we would come back in, and you're very dependent on everything working just right. As you come into the atmosphere, you're rubbing along that atmosphere and you're heating up, but you're also slowing down. And so eventually, and it takes us 10,000 miles to slow down enough that we can land. So we start 10,000 miles from our landing point, from the airport where we're going to land, before we are slow enough to be able to land. And then the space shuttle, like a airplane, actually like a big glider, would circle around and then we'd land. The newer spacecraft, these capsules now just come straight back down, and then they put parachutes out and they parachute down into the water. The space shuttle doesn't fly anymore. It was retired and about 10 years ago, and it doesn't fly anymore. But we now fly in capsules. The astronauts that are going up to space station fly in capsules. So anyway, that's just kind of an overview of what it's like to fly in space. And I was very blessed to have that opportunity to do it. And you guys are lucky, because it's becoming more and more commonplace. And you guys might have a really opportunity to do that some days, but you got to study hard, got to learn your lessons, and you've got to obey the rules pretty much, and be yourselves. But just in everything you do, just do the best you very can, and that would set you up for all kinds of good things. Maybe not being an astronaut, but being anything you choose to do. If you like doing it and you do the best you can, you'll be good at it. So anyway, let me see if there's anything else that I could do that. Oh, there was some questions about how far is it between stars? You know, we didn't go very high above the Earth, just hundreds of miles is all we are above the Earth. The moon seems like a long ways away. It's 250,000 miles away from Earth, but it's nothing like stars. Stars are light years apart. And a light year is how far light can go in a year. And light travels at, oh man, I'm trying to remember the number. Anyway, I know that it's about 175,000 miles a second. So it is really moving fast. And how far could you go in a year at that speed? Wow, it's phenomenal distance. And stars are many, 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 many light years apart from each other. And they fill up things called galaxies. We live our Earth is in a galaxy called the Milky Way, and our sun is called the sun or Sol. And it's one of a million or more, or maybe a billion stars just in that galaxy. And there are billions of galaxies in the universe. Somebody asked, where does space end? We don't know. We do not know where it ends. It is a pretty big place. And so that's kind of an idea, you know. So people ask me, have you ever seen any aliens? Well, no, I haven't. But they'd have to come a long ways to see us, just like we'd have to go a long ways to see them. So it's no aliens, but here's some strange sounds sometimes in space. Sometimes a space shuttle would creak or moan, or you get a click if a piece of space junk or something would hit it. And you're glad that it wasn't impacting your crew compartment or something like that. But other than that, but seeing amazing things, yes, I saw a lot of amazing things. You can see the stars a little bit differently and more clear from space than you can from Earth, because you're not looking through the atmosphere. So they have different colors and are very, very bright and beautiful to look at from space. And the Earth, of course, is gorgeous to look down on. We spend a lot of time doing that. And now I'd just like to take some time here. If you have some other questions that I didn't answer, or I can try to answer for you. I know there's lots of questions about space, but that'll be fun.
What was it like when you were in the space shuttle? How did you eat and sleep?
Oh, how do you eat and sleep? Our food comes packaged, but it's dehydrated. That means all the water has been taken out of it. So the packages they're little cups about this size with saran wrap like over the top, and all the water's been taken out. So it's very dry. So what we do is we use something that looks a little bit like a needle, like a shot needle, and put just the right amount of water in it. They tell you how much water to put in it. You inject it with that much water, and then you mush it around, and then you can put it kind of in a little oven if it needs to be heated up. And then you can take a pair of scissors and cut the saran wrap around the edges, and then you can eat it with a spoon, because it will still stick to the spoon in space, which is great, because then you can dig out a spoon of it and it'll stick to the spoon and you can get it in your mouth. If it wouldn't stick to the spoon, it'd be kind of like, sometimes for a snack, we'll eat M&Ms. They give us M&Ms. Those are kind of fun. But if they come out of the package, they just go all over the place because they don't fall down to the floor. So they spread out everywhere. So you got to be careful that you can collect them all back again. And so that's how we do that. And then sleeping, you just kind of crawl. They have these little kind of cloth, like they're like a sleeping bag, and you get into it, and they've got Velcro on the ends of it. You know what Velcro is? Do they know what Velcro is? Okay, yes, Velcro is the sticky stuff, and they've got little snaps. So you can just get in there, get in your sleeping bag, your arms will be out to the side, and then you just take the corner of the bag and you Velcro it to the wall or the ceiling or anywhere you want. And you can be upside down, sideways, backwards. It doesn't matter, because in 0G, it doesn't matter. So you just stick yourself kind of somewhere out of the way, and you generally put on a sleep mask to cover the light from your eyes, and actually put in earplugs, because the space shuttle is a little noisy because of all the pumps and fans that are running to keep it going and pump the air around. And then you just kind of relax, close your eyes, and see if you can go to sleep. And generally you learn how. Now, the first night I had a lot of trouble going to sleep. I was just too excited. But after that, I didn't have any trouble going to sleep. But I did have a little trouble because it didn't feel quite right. Being in 0G is like you're not laying on anything. You're just kind of floating the whole time. And so it feels kind of weird. And so what I did is I took a pad and put it behind my head, and then put a Velcro strap around the pad and tightened it so that it felt like that pad was being pulled up the back of my head. And it felt just like I was laying on a pillow. And it was, Now I look kind of weird with this strap around my head and this pad on the back of my head, but it felt to me like I was sleeping in bed. And that helped me to sleep and really help. So we do have to sleep in space just like you do on the ground. We can't stay awake the whole time. So they allow us time off. We get about 10 hours off for sleep. So that gives us an hour getting ready for sleep, 8 hours for sleep time, and then an hour after we get up to eat breakfast and get dressed and get ready for the next day.
Thank you. They've come up with some questions, so I'm going to kind of skim through it and see
Sure.
what you might not have covered already, because you've already looked at some of them and they're
Yeah,
like,
some
oh,
of
that's
them I
my
have,
question. He's answering my question. So we have a lot of interest in the sound barrier because we've studied sound waves a little bit. And
Right.
so they're wondering whether you can hear sounds out in space or whether they can't hear it because there's no particles for the sound waves to go through. And then they're also wondering about what was it like to break through the sound barrier when you came back?
Okay, I'll start with breaking through the sound barrier. And I have been fortunate because I've done that before in the jets that I flew. So I've been through supersonic in the jet, going, Mach 1.5 or something like that. But it's not the same as in the space shuttle, because the space shuttle gets there pretty quick. We are going about Mach 1 about 40 seconds after we launch with this great big old vehicle. And what it is just kind of shakes the vehicle a little bit, makes it shake around a little bit, and then it settles out and it's fairly smooth as we get faster and faster. By the time we get to orbit or get to a speed that's fast enough to keep us in orbit, we are doing Mach 25. So I've gone Mach 25. That's how fast the space shuttle would go, which is really fast.
I'm not sure we have any comparison to what Mach 25 is.
No, we don't, other than the space shuttle. No,
Okay.
the fastest airplanes have gone maybe Mach 3. That's the very, very fastest airplanes we've ever had. They have some drones that are test vehicles that are hypersonic that have gone Mach 6 or 7. But the space shuttle has gone Mach 25. That's very, very fast. And then coming back down, as you come out of the sound barrier, the vehicle actually shakes a little bit too and shudders a little bit as you're slowing down through Mach 1 so that you can slow down enough to land. So that's going supersonic. Now up in space, you don't know anything about, you're going very fast. You're going Mach 25, but you don't feel anything because there's really nothing for the vehicle to react against. There's no air, so anything like that. So you're just going fast through this, and you don't slow down because there's really nothing there to react against to slow down. So you just keep going that speed. That's why the engines can shut off and you'll continue at that speed and you continue in orbit without actually putting on the engines again. So you can stay in orbit for a very, very long time. That's what the space station is doing now. Every now and then they have to give it just a little bit of thrust to get it going faster again, and then it just stays there for weeks and months on end.
Wow. You talked about there were lots of amazing things that you saw. Can you give us a few examples of those?
Boy, I know that in a game called Trivial Pursuit that was popular years ago. I don't know if you guys know about that or not, but they used to ask you questions and say, what is the only thing that's visible but with the naked eye from space? And supposedly they said it was the Great Wall of China. Well, you can see a lot more than just the Great Wall of China. I mean, other details, but you can't really see small things. You can see the Earth just as one big Earth, and you can tell whether there's land or ocean because of the color and things like that. And so an amazing thing to look at is look down and see these countries as they come by. And if you've studied a little geography, you can tell by the shape of it and where it's located in the Earth. You go, oh, that's Japan. I recognize that from my study of geography. And this is the United States, and that's Baja California, or that's the British Isles, that's England. You can recognize those big things, but you can't see really any detail down on the ground unless you use cameras with great big lenses or very powerful binoculars, and then you can see smaller things. You can sometimes see big interstate roads and highways. If they have a long straight section, then you can kind of recognize that.
Okay, a lot of our kiddos are really interested in black holes.
Okay.
And I hope you haven't felt the pull of one, but I'm wondering, I'm sure you have some knowledge about black holes and they would love to hear about it. And they're even interested in something called wormholes.
Okay.
So they wanted your perspective on that. Go ahead and sit down.
You guys are really deep into some really theoretical mathematical things. Although black holes, I think they've decided they really exist. Black holes are massive, massive amounts of gravity concentrated into very, very small amounts. So something like the size of my fist might weigh billions and billions and billions of pounds. That's how compact it is. And gravity is all caused by the amount of mass or amount of material that there is. And so as something has more and more gravity, it pulls things more and more rapidly into it. And a black hole is one where the gravity pull, there's so much mass inside it that it actually pulls light into it. And that's why it's called a black hole, because you can't see anything, because the light it's not radiating any light, so you can't see it. It's pulling everything into it. And it's just a massive black hole. You don't want to get close to it because you can't get away. It just keeps pulling you in and pulling you in until you become part of that massive core that's at the inside of it. So that's what a black hole is all about. It's just a massive gravity hole that pulls everything that goes around it into it. Now, a wormhole is a theoretical way to go very, very long distances in a short period of time. That could take you maybe from one galaxy to another, just through this, what they call a wormhole. And I can't explain it much different than that, other than that if you get into a wormhole, when you come out of it, you're somewhere else, and it could be a long, long ways away. And that's what a wormhole is. And I'm sure in a lot of science fiction books and things like that, they talk about wormholes, and that's how people can go from galaxy to galaxy. Nobody's discovered one, but theoretically, I guess they can exist.
Awesome. Were there any problems in your space mission?
Yeah, in a couple of our missions, we had some problems. We had a communication antenna on my first flight that broke. And because it broke, we couldn't send down data to the Earth very well. So during the spacewalk that Kathy and I were on, after we finished the satellite refueling demonstration that we were doing, then we went down to where that communications antenna was and braced it in a position such that we could still use it. And we then point the orbiter rather than the antenna pivoting around and being able to point where it needed to. We locked it in place so it pointed, but we could still use the antenna. And so then we would just maneuver the entire spacecraft around until the antenna was pointed at the satellite that we needed to talk to. So that failed, and that caused us some problems with communications. On another flight, we lost a couple of what we call our reaction control jets. Those are the little rockets on the side of the space shuttle vehicle itself that we use to maneuver ourselves. So if we're flying along like this and we need to turn around, we fire a jet on the nose down like this that pushes us around like this, and then we have to stop it. So then we have to fire one on the other side to stop it, and then we can be in position. We lost a couple of those jets, so we weren't able to do all the maneuvers that we wanted to do. We could only do maybe yaw maneuvers and stop and start. If we got a pitch maneuver, then we'd have to roll and then do a yaw maneuver to stop it because we lost the pitch jets that we had on the flight. But the Mission Control Center, which are all the people on the ground that are helping us out, they figure out how to do those maneuvers and they help us with them to be able to do those. So if you wanted to move, say I wanted to move this pencil and I wanted to make it go like this, but I can't, I don't have the jets like that. I could yaw it around like this, roll it, and then use another yaw maneuver to go like that, and then it would be pointed up. So you can change the way that you do things and still get to the place that you're looking to get.
Fascinating. Max, what's your question?
I have a question.
Yes.
That, is it true that if you get pulled into a black hole, it would be so small that it rips your atoms into pieces, and some people, and it's like you're getting spaghetti bodies?
Is it true that if you go into a black hole,
Yeah.
you become so small, it would rip your atoms into pieces and you would be spaghettified?
Oh yes, you'd be
That's
spaghettified. You would be crushed to a very, very small amount, and something that could not be seen at all.
Oh, goodness.
Could be
Oh.
crushed down into just a little piece of something.
Okay, Michael. Michael, you were raising your hand. Do you have an extra question? No? I have plenty here. Go ahead.
Um, what does it feel like when you're floating around in space? Does it feel like you're just standing around?
What does it feel like when you're floating around in space? Can you tell us a little bit more about like when you went on a space walk?
Okay.
It's so fascinating and surreal.
Yep.
Yeah.
Well, it takes about 4 hours to get ready to do a spacewalk, because you have to put on the spacesuit, but that starts by putting on a pair of underwear that kind of covers your whole body like a jogging suit, but it has a bunch of little capillary tubes in it that you run cold water through, because in space there is no convection. Now, convection is where if you have a container of water and you put it on the stove, you put the heat from the bottom and it heats up that water. But that water, as the water gets hotter, that water goes to the top and the cold water sinks, and then it heats it up kind of uniformly. But there's no convection in space. And there's no evaporation. So as you work hard in a spacesuit, and because it's pressurized to keep you alive, it's very, very hard to move around in it. So you have to do everything very, very slowly and get around in it. And as you're pushing against that suit, you're doing a lot of work. So you get hot, but you can't cool yourself down because your body isn't sweating, and that sweat does not evaporate. So all that heat just stays wherever the blood leaves it in your thing. So you run cold water over these tubes to take that heat away from you so that you don't get overheated while you're doing all this work in the spacesuit. So that's just one of the things that you have to learn. The other thing is they call it space walking, but we really don't use our legs very much. Our legs don't have hands to grab onto. And so when we move around, we grab onto a handhold and move ourselves over there and then grab onto the next one and onto the next one. And so we move mainly by using our arms to take us from one place to another. And our feet are just kind of floating behind us. Now to do any work, sometimes we have to grab onto something. Like I was going to grab onto this camera here. If I wanted to pull it back, then it would pull back. And by touching it, though, I would push myself away from it, because for every action, there's an equal or opposite reaction. And so that is how we have to move very, very carefully, and we have to react against something. So we have to hold on to one thing if we're going to grab another thing and move it. Because if I wasn't holding on to this, as I move something this way, my whole body would move this way. And so we have to be able to grab onto one thing or hold ourselves in one place to react against it to be able to move anything. So it takes a lot of training to learn how to do a spacewalk and to go out into space. And we do most of that training underwater. Underwater in a great big giant pool is how we learn how to react against things, because being underwater is kind of similar to being in space. So if you ever want to do it, like this summer, if you get a chance to go swimming in a swimming pool, go underwater, close your eyes and just stretch out. And you can feel that you can move around like that. And that's kind of how it's like. That's a lot what it's like to be in space and floating.
Wow, that's fascinating.
And then the other thing is going out in space, because the pressure has to be so reduced in the suit so that we can even move it with our arms and with our hands and that. They worry about us getting a sickness called the bends. And so we have to get all the nitrogen out of our system. It's kind of like scuba divers going down very deep in the ocean. When they come up, they have to breathe out all the time because the pressure is reducing. So we have to get rid of that, and we have to breathe pure oxygen for about 4 hours before we go out into space. So we have to just sit there, Velcro to the wall kind of in our spacesuits and just breathe pure oxygen for a while before we can go out where we can depressurize our suits and go out into space.
Wow, that is so fascinating. Thank you so much for your time. I am so grateful for you and grateful for your willingness to share your time with us. I am we are all so deeply grateful. Can you guys say thank you?
Thank you.
You're welcome. And it was a pleasure for me to be able to share some of those experiences with you guys and get you excited about space. Space is an exciting topic.
Yes, we are all so excited about it. We've been able to study in different kinds of units, and everything kind of brings us back to space. So when we're talking about sound, we wanted to talk about space. And when we're talking about obviously the solar system and different laws like gravity, everything brings us back to space because that's something that is like it's so beyond our comprehension that it's such a fascinating thing. So we just wanted to say thank you. We're so grateful to you. Thank you so much.
Thank you, Jessica. And thank you, class. You are a great audience.
Everybody
Great to see you.
Everybody say thank you.
You're welcome. Good to see you. Good luck to you guys in your careers. Study hard.
Bye-bye.
Bye-bye.
Eddie.